of the alcohols. Is it right? So in that one we had seen some of the properties. What are the properties we had seen here? Alcohols are undergoes the dehydration reaction. Based on the temperature will hit as different products. The alcohols are here, it undergoes the dehydration reaction at high temperature, means they form as alkenes. At the same time, if the alcohols are, it undergoes to the dehydration reaction at low temperature in presence of concentrated sulfuric acid, means it forms as a ethers. After that, we had seen some of the reactions also.
So can I explain the last part of yesterday's class? I was disconnected.
Yeah, right, ma. So last part, once again, I'm going to be explained here. So actually, alcohols are there, mama, here. Alcohols are the primary alcohols, secondary alcohols, and tertiary alcohols. Now, in this one, once you check it out, means here, so primary alcohols are treated with a strong oxidizing agent, means they converted into the carboxylic acids. Okay, that means the OH attached to carbon atom it undergoes to the complete oxidation and it forms as a acetic acid. It is converted into the carboxylic acid group. Okay, the OH attached to carbon it is oxidized here and it is converted into the carboxylic acid. Okay, now in the second one, so primary alcohol. So primary alcohols are converted into the primary alcohols are converted into carboxylic acid. Then what about the secondary alcohols? Secondary alcohols are, first you can check it out here. Secondary alcohols also it is converted into the carboxylic acids, but it has the less number of carbon atoms. How many carbon atoms less it is there means here, wherever it is going to be break here. Okay, exactly adjacent to the OH group carbon. It undergoes to the cleavage and this part it is converted to the carboxylic acid. If the terminal one is methyl group, it is there means is this one is methyl group means it is converted into the carboxylic acid, carbon dioxide. Okay, so this one is converted into the carbon dioxide. Now you got the clarity?
Yes, sir.
Okay, and same one more condition. This is also secondary alcohol. This is also secondary alcohol. If you observe clearly here, so this also it is treated with the okay. So this is also it is treated with so acidified KMnO4 or acidified K2Cr2O7 means here. So in this one, so OH attached to carbon is converted into the carboxylic acid, and the carbon which is attaches to the OH attached to carbon, that carbon also it is converted into the carboxylic acid. But if it is last one is terminal one is methyl group means it is converted into the carbon dioxide.
So if there is another carbon carbon group before methyl, then it will turn into carboxylic any carboxylic acid. But if it's only methyl, then it will directly turn into carbon dioxide.
Well, yes, ma. Yes, ma. Okay, is that clear? And the last one. So last one we are taking as a tertiary alcohol. Actually, tertiary alcohols are they does not give the positive test with the acidified KMnO4 and acidified K2Cr2O7. Okay, so actually, so tertiary alcohols are they does not give any positive test. Okay, tertiary alcohols are they does not give any positive test with acidified KMnO4, acidified potassium permanganate or acidified potassium dichromate. Okay, but so because of all these are the selective reducing, selective oxidizing agents now. So by changing the reaction condition, but selective conditions, condition is the selective conditions. But selective conditions. So first, the tertiary alcohol is converted into the ketone CH3 bond, C double bond O bond CH3. So first of all, it is converted here. So due to the selective reaction condition, first it is converted into second ketone. It is converted into ketone. Again, if it undergoes to the pop-up rule, okay, pop-up rule. So what is the pop-up rule means? Whatever the lower alkyl group it is there. If we cleave this one means this one and this one it is similar only na. Okay, so this carbon is converted into the carboxylic acid CH3 COOH and terminal is methyl group it is there. So if the terminal carbon is converted into the carbon dioxide. Now we got the clarity. Condition applied. Condition applied. So when it is means selective conditions, so in presence of some selective reaction conditions, again tertiary alcoholis reacts with the acidified K-4 or K2Cr2O7. First it is converted into the ketone. First it is converted into the ketone. Okay, so then it undergoes to the cleavage. Further oxidation it takes place. Further oxidation means it follows the pop-up rule. So what is the pop-up rule means here? So ketone adjacent here. Ketone adjacent water, ketone beside ketone bond is going to be break. How it is going to be break means it breaks towards the lower alkyl group. It breaks towards the lower alkyl group, and this carbon is converted into the carboxylic acid. Now you got the clarity. Aditi got it?
Yes, sir.
Right, ma? So this is the one reaction. Okay, acidified KMnO4. So do we had seen the reaction with copper metal? We didn't see the reaction mechanism with the copper metal, na? Lucas reagent we had seen, and other reaction with other halogens also we had seen here. Okay, so next reaction with hydrogen halide, so Bruce process also we had seen. And what is the another method we are having means here? Next, reaction with copper metal. Reaction with copper metal. Reaction with copper metal. Okay. So what is the reaction with copper metal? So this reaction also we can call it as a dehydrogenation. Dehydrogenation reaction. Dehydrogenation reaction. So what is meant by the dehydrogenation reaction? Asti? Dehydrogenation. Dehydrogenation is different. What is meant by the dehydrogenation? What is meant by the dehydrogenation? Removal of the hydrogen
Sir, is it
molecule.
removal of hydrogen
Very good.
molecules?
It is the removal of the hydrogen molecule is called as here dehydrogenation reaction. Okay, so it is also one of the identification test of the primary alcohol, secondary alcohol, and tertiary alcohol. Okay, it is also one of the identification test. One of identification test. Identification test. Okay, sir, how you are going to identify that the primary alcohol, secondary alcohol means? First, I'm taking as here primary alcohol. Primary alcohol. The vapors of the vapors of primary alcohols are passes through the copper metal at 300 degrees Celsius. 300 degrees Celsius, so we can convert it to the Kelvin formation. Na? If you convert it to the Kelvin formation, is how much we can write as here? 573 Kelvin. Okay, so we can convert it into the 573 Kelvin. Okay, so when the vapors of primary alcohols are passes through the copper metal at 573 Kelvin or 300 degrees Celsius, they converted into aldehyde. So how it is converted into the aldehyde means we are removing the hydrogen molecule. Okay, so now let us see. They converted into aldehydes. I will give one example. I'm taking as a ethanol. So what is the molecular formula of the ethanol means here? CH3 bond, CH2 bond, OH. Okay. So the vapors of the ethanol is passes through the copper metal. Okay. So ethanol is passes through the copper metal at 573 Kelvin mark. So that means we have to remove this hydrogen. If you remove this hydrogen means here, it is converted into CH3 bond and CHO. So after removal of the two hydrogens, it contains only one carbon, one oxygen, one hydrogen. One carbon, one hydrogen, one oxygen means that we can write as a CHO only na plus and hydrogen molecule. Okay. Now it is converted into aldehyde or which one? CHO group is called as a aldehyde or ketone? Aditi.
So can you repeat again?
Is CHO group is called aldehyde or ketone? Is CHO group is called aldehyde or ketone?
Sir, it's an aldehyde, right?
Very good. So it's a aldehyde. Okay. Now I'm going to take as a secondary alcohol. That means 2-propanol I'm taking. CH3 bond, CH bond, OH bond, CH3. So this we can call as a secondary alcohol. Okay. The vapors of the secondary alcohol is passes through the copper metal at 573 Kelvin. Okay. At 573 Kelvin means from here also we are going to remove the hydrogen. If you remove the hydrogen like this means here in between the carbon and oxygen it forms as a one new bond. CH3 bond, C double bond O bond CH3. Okay. Plus hydrogen. Now secondary alcohols are converted into which functional group we got after removal of the hydrogen? Either it is aldehyde or ketone functional group.
So your voice was breaking. Can you repeat again?
My voice was breaking, ma.
No, so there's something wrong with my internet.
Okay. Ma here, after secondary alcohols, if treated with the copper metal at 573 Kelvin, ma, it forms as a one product. So what is the name of the product? What is the name of the product?
So pro 2 on.
Prop 2-on, propane 2-on. Propane 2-on or 2-propanone also we can write. So what is the name of this one means what we can write as means here. This also we can write as a 2-propanone also. Okay, this also we can write as a 2-propanone. Now you got the clarity. Now one more example. Last one. Here, if CH3 bond CH3 bond CH3 bond OH. First of all, the given alcohol is the primary alcohol, secondary alcohol, or tertiary alcohol?
Sir, it's a tertiary alcohol.
Very good one. So the given one is here, tertiary alcohol. Okay. If the vapors of the tertiary alcohol is passes through the copper metal at 573 Kelvin. Okay. If it is passes copper metal at 573 Kelvin means it undergoes to the dehydration reaction. And behalf of dehydrogenation reaction, it forms as a dehydration reaction. That is the exception case here. Okay, so what is the exception case means here? When the tertiary alcohols are passes through the copper metal at 573 Kelvin. Okay, at 573 Kelvin by losing of water molecule. By losing of water molecule. Okay, so it forms alkene. It forms as a alkene CH3 bond CH3 double bond CH2 is going to be formed. So generally primary alcohol and secondary alcohol we removed as a hydrogen molecule. But in tertiary alcohol, to remove the hydrogen, there is no hydrogen at the tertiary carbon atom. Is any hydrogen is there at the tertiary carbon atom? Is any hydrogen is there at the tertiary carbon atom in tertiary alcohol?
No, sir.
No. So that's why it does not undergoes to the dehydrogenation. On behalf of dehydrogenation, it undergoes to the dehydration and it forms as a alkene. Okay, so it forms as a alkene. Okay, now, so it is also one of the identification tests. So based on this one, we can identify either the given alcohol is a primary alcohol or secondary alcohol or tertiary alcohol. Sir, how we can identify means primary alcohols are they give as a aldehydes, secondary alcohols are they form as a ketones, and tertiary alcohols are they form as a alkenes. Now we got the clarity. Aditi, you got the clarity or no?
Yes, sir.
Okay, right. So next we'll go for the next reaction. So what is the another reaction we are having here? Here, alcohols are reacts with bleaching powder. Okay, so reaction with bleaching powder. Alcohols are reaction with bleaching powder. So what is the molecular formula of the bleaching powder, ma? What is the molecular formula of the bleaching powder?
CaClO taken twice.
CaOCl taken twice. So this we can call as a bleaching powder. Bleaching powder is act as oxidizing agent or reducing agent. Aditi, is bleaching powder act as an oxidizing agent or reducing agent?
So it will act as an oxidizing agent.
Very good. So bleaching powder act as an oxidizing agent. So because of it releases as a nascent toxin. Okay, so whenever it dissolves in your water means it releases the nascent oxygen. That nascent toxin is decolorize the water and at all. Okay, and it removes the color also. Removal of the color property also we can call it as a bleaching agent. Now, so when ethanol is, so we are taking as a ethanol. So ethanol molecular formula is CH3 bond, CH2 bond, OH. Okay, so ethanol is treated with CaOCl2 in presence of water molecule. In presence of water molecule, it forms chloroform CH, Cl3 plus HCOO taken twice, Ca. It forms as a calcium acetate. It forms as a calcium acetate. So chlorine, calcium acetate is going to be formed. Okay. Calcium acetate is going to be. So this is the product. Okay. So this is the product is going to be. So whenever it is treated with ethanol, okay. So when the ethanol is reacts with the bleaching powder means it forms as a CHCl3. CHCl3 is called as a chloroform. CHCl3 is called as a chloroform. Now you got the clarity, right, ma? Is any doubt it is there in this one?
No, sir.
Can I explain the mechanism? Sir, how it is converted into the
Yes,
chlorine?
sir.
Okay, so can I go for the mechanism? First of all, I'm taking as a calcium oxychloride. That is only we can call as a bleaching powder. If the bleaching powder, if it dissolve in a water, if it dissolve in a water means it releases the chlorine gas and it forms as a 2 moles of the calcium hydroxide. Okay, it releases the chlorine gas. Chlorine gas also it acts as an oxidizing agent. You know that one? Chlorine also it acts as an oxidizing agent. Whatever the water we are having, that is chlorinated water only. So nowadays every home we are using as a some RO plant. We are using a RO plant or not?
Yes, sir.
Okay, that RO plant also it contains the chlorine here. Chlorine chemical it will be there here. Okay, so whatever the chlorine it is releases, that it is reacts with CH3 bond, CH2 bond, OH. Okay, so whatever the chlorine is reacts with 3 moles of the Cl2 in presence of sunlight. Okay, it is reacts with chlorine. Okay, if it is reacts with the chlorine means here alpha carbon atom, whatever the hydrogens are there, all that hydrogens are replaced by the chlorine. All that hydrogens are replaced by the chlorine means it is converted into CCl3 bond CH2OH plus and 3 moles of HCl is going to be formed. 3 moles of HCl is formed here. So whatever it is formed, okay, so whatever it is formed here, that again CH2 bond OH bond CCl3. It is treated with the calcium hydroxide. It is treated with the calcium hydroxide. If it is treated with the calcium hydroxide means, okay, in this one, it bonds going to be break here. If you take 2 moles of this one means here, the bond is going to be breaks here and this one is converted into the CHCl3. Sir, how many moles of the CHCl3 is going to be converted? Means it is converted into the 2 moles of the CHCl3 and we have it one calcium atom and 2 oxygens are there. So one calcium atom and 2 oxygens are, they reacts with one and they converted into format HCOO bond Ca bond HCOO. So this is the products it is going to be formed. This is the products is going to be formed. So what we got ma? Finally got as chloroform and you plus here calcium acetate. Okay, so finally got as a chloroform and calcium acetate. Now you got the clarity. Aditi, you got the clarity?
Yes, sir.
Right. So like that. So one more reaction also it is there. So chloroform reaction, like generally we can call it as a haloform reaction. Idoform also. Ethanol is it undergoes to the haloform reaction. Ethanol is it undergoes to the haloform reaction. Okay. Next one is haloform reaction. Okay. So what is meant by the haloform reaction means here? Alcohols reacts with halogens in presence of alkaline solution. Alkaline solution. Okay, so they reacts with halogens and they react in presence of alkaline solution. Shall we try one example? For example, again I'm taking as ethanol, CH3, CH2OH. Okay, it is treated with halogen. Now I am taking as a chlorine. Okay, in presence of NaOH I am taking. NaOH I am taking. Okay, so when the ethanol is treated with chlorine in presence of NaOH, it is converted into the chloroform. What is the molecular formula of the chloroform? CHCl3 plus. What is the byproduct it is formed? Means HCOONA plus. It is converted into sodium chloride plus and it is converted into water molecule. It is converted into water molecule. In conversion in this process, how many moles of the chlorine we have to take? Means we can take as a 3 moles of the chlorine. Okay, how many moles we have to take in here? So 3 moles of the chlorine. If you take the 3 moles of the chlorine means it is converted into 1 mole of the chloroform. Okay, and in this one, if you take 4 moles of the NaOH, if you take 4 moles of the NaOH means it is formed as here 3 moles of the NaCl plus 3 moles of the water molecule. Okay, now equation is balanced or not? Now equation is balanced or not? Aditi?
Yeah, sure.
So sometimes in examination, some question they're asking, is alcohol, is it gives us a positive iodoform test or not? Is alcohol, sir, it gives us a positive iodoform test or not? That is the question. Whether they'll give the positive iodoform test or not, alcohols. Primary alcohols and secondary alcohols are they give us a positive iodoform test. Primary and secondary alcohols. Secondary alcohols gives positive iodoform test. Iodoform test. Positive iodoform test. Okay. So what is the example of the secondary alcohol? Means 2-propanol. CH3 bond, CH bond, OH bond, CH3. If this one, if it is treated with I2 plus KOH. So to make you confused, I'm going to write this one in this formation. Okay. So to make you confused, sometimes in examination, how they are writing this same question means here. Now, secondary alcohol is treated with sodium hypohalite. Sodium hypohalite. So what is the molecular formula of the sodium hypohalite? Means NaOI. NaOI. Is any doubt is there, sir, how it is forming as a NaOI? Aditi?
So can you explain it once?
Ma?
Can you explain it once?
Yes. Yeah. Actually, reaction is carried out in presence of I2 plus NaOH. Na? Okay. In this one, it forms HI plus NaOI. HI plus NaOI. So this NaOI only we are using as a reaction. This NaOI only we are using in reaction. Have you got the clarity? When the iodine is reacts with sodium hydroxide. When the iodine is reacts with the sodium hydroxide means it forms as a hydrogen iodide plus sodium hypoiodide. This we can call as a sodium hypoiodide. Got it? Okay. Sir, what is the product it is going to be formed means alpha carbon atom is converted, only one carbon, not two here. So only one alpha carbon is converted into the iodoform. Okay, so only one alpha carbon is converted into the iodoform. That means, so it converts into 1 mole of the CH I3 plus. Sir, other one. That means this carbon it undergoes the oxidation. It undergoes the oxidation means we are removing the 2 hydrogens from here. If you remove the 2 hydrogens means it is converted into CH3 COONA and it forms 3 moles of the NaI is the byproduct and it forms 3 moles of the water molecule. Got it? This equation is balanced or not? Once you check it out, ma? Here 2 hydrogens we removed, here 2 hydrogens. 2 plus 2. So 1, 2 moles. A total 4. Total 4. Again. I think so. If you take the more number of moles of the iodine, so how many moles we can take? Means 4 moles and 6 moles of the 5 moles of the water molecule. Now we can take acid. Yes. In this condition, acetone you can take means here. So 5 moles here. 5 moles of the NaI and 5 moles of the water molecule is going to be formed. Okay. 5 moles of the NaI plus 5 moles of the water molecule is going to be formed. Okay. Got it? Same reaction we are using for aldehydes and ketones also, Aditi. Same reaction we are using for aldehydes and ketones also. Sir, which aldehydes mean? The aldehydes which contain the methyl group. Alpha carbon, it has to be methyl group. Okay, sometimes they're asking the question, which of the following compound is it gives as a positive iodoform test? Okay, for example, let us see CH3, CHO, acetaldehyde. Acetaldehyde, it gives as a positive iodoform test. Sir, how you are telling that acetaldehyde, it gives as a positive iodoform test means here, alpha carbon atom is methyl group. Acetone, CH3 bond, C double bond O, bond CH3. Okay, acetone also it gives as a positive iodoform test. How it gives as a positive iodoform test means both sides it has a 2 methyl group, it is that. And acetophenone also it gives as a positive iodoform test. Upcoming chapter question, interlink question. C double bond O, CH3. So this one also it gives us a positive iodoform test. So why means due to the presence of the methyl group. So due to the presence of the alpha carbon methyl group, it gives us a positive iodoform test. But benzophenone does not give the positive iodoform test. C double bond O, bond C double bond. So this one it does not give the positive iodoform test. Why it does not give the positive iodoform test means there is no methyl group. There is no methyl group. Alpha carbon functional group adjacent carbon. Functional group adjacent carbon, it has to be methyl group. Then only it gives us an iodoform test. In case, for example, if they had given C2H5 bond CHO, it does not give the positive iodoform test. It is also, it does not give the positive iodoform test. Because of, in place of methyl group, we are having the ethyl group. If it is having the ethyl group means it does not give the positive iodoform test. Got it? Aditi, you got the clarity?
Yes, sir.
So it is upcoming interlink chapter here. Okay, alcohols and aldehydes and ketones also they give us a positive iodoform test. Which one they give means which they contain the methyl group. Alpha carbon is the methyl group. For that only we can consider. Okay. Right one. And what is the next one? It is there means here. So we have a methanol ethanol preparation. We have a preparation of the methanol and preparation of the ethanol. It is there. Okay. So how are you going to prepare the methanol, ma? Do you have any idea? Next one is preparation of the methanol.
No, sir.
Methanol also we can call, we can use some name. Methanol. So methanol is also we can call it as a wood spirit. This also we can call as a wood spirit. Sir, why we are calling as a wood spirit means here. So methanol is obtained destructive distillation. Destructive distillation of wood. Okay, so methanol is obtained by the destructive distillation of the wood. So due to that reason only, methanol also called as a wood spirit. Okay, and so we can prepare commercially. Sir, how we are going to prepare the methanol commercially means here. So methanol is commercially prepared from the water gas. What is mean by the water gas? What is mean by the water gas? What is mean by the water gas?
So is it something carbon monoxide plus H2?
Very good, Aditi. It is a mixture of carbon monoxide and hydrogen. Okay. So when water gas is, it undergoes to the oxidation reaction in presence of zinc oxide Cr2O3. Okay. So zinc oxide in presence of Cr2O3 means it undergoes the oxidation and it is converted into methanol CH3OH. Okay, so how we are going to prepare as a methanol means here, methanol is obtained commercially obtained from here, so water gas. So when the water gas is, it undergoes the oxidation, that means reduction, sorry, it's not the oxidation here. When the carbon monoxide is, it undergoes to the reduction reaction in presence of zinc oxide and Cr2O3. It is converted into the methanol. So methanol is highly poisonous. Methanol is here highly poisonous. Okay, so methanol is highly poisonous. Okay, so whenever you take the methanol means it is not used for the drinking process. It is not used for drinking process. Methanol is not, it is not used for drinking process. Drinking process. Okay, so if it is had this one, if they had the methanol means it causes blindness. It causes here blindness. Okay, so that is only with the methanol also we can call as a slow poison. Okay, so without knowing only slowly causes the blindness. Okay, so then where we are using as a methanol means methanol is used in making of paints. It is used in making of paints. Okay, and varnishes. Okay, shellac. Okay, shellac and dyes. So what is mean the dyes means? Dyes is nothing but here colors. In the making of colors also it is used here. Clear? Still any doubt is that? So remaining preparation of the ethanol one, it is that we will discuss in tomorrow class. Then we'll go for the chemical properties of the phenol. Okay, ma? And tomorrow you're having the test based on preparation of the alcohols and physical properties and chemical properties.
So can I send the notes? Like I missed a few classes in between, so I didn't write all the notes.
Okay, ma. Okay. I'll forward the notes.
Thank you.
Okay.